All right. Well, good morning and happy Friday. We will take a look. Today we're going to look at what I call function writing strategies, and we will work through kind of just writing a function together. And my hope is that it will help you understand like how to go about writing a function. All right. And so here's a little bit of text and reading and whatnot, and we'll start off by kind of going over the basics of a function. So Um, in R, when you define a function, you do so by writing the keyword function, and then you put in kind of whatever arguments you want. So here I've got argument one and two and whatever. Within the body of your function, you have different expressions, and then usually you end your function with a return statement saying this is the value that's going to be returned when this function is executed. All right. So, um, at a very simple case, you could leave off the curly braces if you only have one line. You could leave out the word return, and the last expression is going to be the value that gets returned. So, so here I'm going to create a very simple function f, and it's going to be a function of x, and the value it is going to return is going to be x times x. Um, when you create a function in R, it is an object, and you can treat it like an object, and you can throw an object into, say, a list. You could, do different things with an object. So here I've created a list, and I've put the function f inside of that. And when I ask, hey, what's the list? It says, oh, yeah, here's your first list element, and it contains a function. If you ask the type of, it will say it's a closure. If you ask for the mode, it will say it's a function. Functions return values. Okay. The To explicitly return a value, you use the word return, the keyword return there. If you don't use the keyword return, then the last expression that gets evaluated is the value that gets returned. And this is actually the recommended style in R, is to use the implicit returns. And so when you look at how functions are defined in R and stuff, and you look at how they're written, they actually often leave out the return statement. It's not wrong to use return statement, and I often use return statements, but this might be the recommended style. Now, one thing to note is that a function is only able to return one object. So if you want to return multiple values, okay, multiple things, um, you have to group them together into one object. So so here I want to return three values. Okay, I'm going to take a function of x. I want to return x. I want to return x squared. I want to return x to the third power. And I have to, in order to get all three of those values out, I have to group them together into a vector. So I create a vector of x, x squared, and x cubed. It gets grouped together. And so it returns one object, just one vector, but that vector has three values. Okay. Similarly, you can have something more complicated. You can have the function return a list, and this list can contain, three values, or, a list, you can put other functions inside of it. You can put, um, other lists inside, right? Lists are very versatile. You can put all kinds of objects in there. So again, if you want to return more than one thing, you have to group them together into one object. So you would have to kind of group them together into a big list, and you can do that. So here I have a named list, and it does that, right? So you can have that. Here, when you define the function, you also provide argument names, and those are going to be, you're defining the names for those arguments. Those are going to be objects with values inside your function environment. Um, and so if so when you call the function, you try to provide values. Um, or you provide values and R is going to try to match them up to the arguments. If you don't explicitly say, hey, I'm putting in this value for X and this value for Y, R is going to just try to match them up positionally. So here I've got, just this very uh, silly function where it takes in the arguments X, Y, and Z, and then it just pastes them together into one string where I say X is equal to X and Y is equal to Y and Z is equal to Z. And so I call the function with values 1, 2, 3, and 1 gets matched with X, 2 gets matched with Y, Z gets matched with 3, and we have X's, it outputs that, okay? Here, if I specify argument names when I call it, R is going to match them up accordingly. So I say Z gets 1, X gets 2, Y gets 3, and R matches it. And so it'll say X is 2 and Y is 3 and Z is 1. Okay, so no surprise there. If you provide the names for some and not for others, R is going to do its best to try to match them. And so this is something R is able to do. Whereas if you try to do something like this in Python, Python will give you an error and it'll say, I don't like the way you're writing your code. But here you can say Y is 2 and also the arguments 1 and 3. And R is going to say, okay, well, I'll put 1 in the first spot, so X gets 1, and 3 in the whatever spot it can fit, so Z gets 3. And here I say Y is 2. I don't have anything for, and also there's a 1, and then X gets 3. And so I get X is 3, Y is 2, and Z is 1. If you give it an argument that isn't used, like M equals 1 here, then R says, what are you doing? Okay, it says unused argument, M equals 1. That's that there's an error there, okay? When you have a function, the values that are used inside that function, they need to, like, values need to exist, okay? So R is going to require a value. So, but if it doesn't get used, then R doesn't care if the value doesn't exist. So, here I have a function. It takes in 4 arguments, X, Y, Z, and W, okay? Now, in the body of the function, though, it only uses X, Y, and Z. Like, the function can take in the value for W, but it doesn't actually use it. So when I call it, I can call the function f is 1, 2, 3, 4, and R has no problem. X gets 1, Y gets 2, Z gets 3, and W gets the value 4. And R runs the function no problem. Doesn't use the value W anywhere. Okay. Over here, I call the function and I only give values to X, Y, and Z. I don't give any value to W. And R is also fine with that because it says, well, I don't know what the value of W is, but guess what? I don't need to know the value of W. I'm not using it anywhere in here. So there's no problem there. Okay. Um, but if I say here, if I call the function and I give a value to X, a value to Y, and a value to W, but I don't give a value to Z, okay, now R complains, okay? Because inside the body of the function, I need a value for X, I need a value for Y, and I need a value for Z, okay? But I didn't give a value for Z, so R complains and says, argument Z is missing, and there's no default values, so I don't know what to do. I don't know what to do. Okay, so so we can kind of handle that situation and provide default values with the equal sign during the definition of the function. So in the function definition, I can say x is 1, y is 1, z is 1. These are going to be the default values. And then if I run the function with no values provided, it's just going to use the defaults for everything. If I provide the value 2, it's going to plug in 2 for the first position x. So x gets 2, and then it uses defaults for everything else. Obviously, you can specify and you can say z gets 3, and then it'll use the defaults for everything else. And we get x is 1, y is 1, and z is 3, and so on and so on. Okay. Um, an important thing to remember is that values created inside a function only exist inside the function. And as soon as the function finishes executing, those values disappear, okay? So in general, you don't want to try to change values in the global environment from within a function. And then if you do want to get a value out of a function, right? Like let's say the function is computing things and like let's say there's multiple things you want to keep track of, right? Like the function returns a number, but also you want to like change the state of something to say like the function has run and stuff like that. Like that needs to be returned. Okay. You need to create like a list that's going to return the values you want. Plus also the list is going to return, the state to like has been run or whatever, you need to and anything you want to get out of the function has to be part of the object that you're returning. Okay. So just to kind of illustrate this, and this is kind of a silly example, but I'm going to create 10 in the global environment. We're going to and we're going to store that as X. Okay. Then I'm going to have a function. This function takes in the argument X, and then but again, this X for the function only exists inside the function definition. All right. We take whatever value of X we have, we add 55 to it, and we store it back into X. Okay. Again, this is the X inside the function. And then we return that value of X that's inside the function. So when I execute this function, here I'm calling f on 10. So 10 comes in, X is 10, 10 plus 55 is 65. Has the value 65, so the function returns 65. Okay. But again, the value of X being 65 only exists inside the function. The value of X in the global environment is unchanged. It's still 10. Okay. Here, X in the global environment is 10. If I plug in 10 into the function, f of X is 65. But again, X in the global environment still remains 10. If you want to change the value in X in the global environment, you have to explicitly assign it. Okay. So here I can execute f of X. That's going to return the value 65. That value 65 gets plugged into X with the arrow key or the arrow sign. So this is going to assign whatever f of X returns, in this case 65, into the name X. And then so now X in the global environment has the value 65. All right. When should you write a function? Okay. So as you code, um, you're gonna have to kind of probably copy and paste your own code at some point. Okay. And so the goal of a function is to create like a small reusable piece of code that you can adapt for different values. Okay. It's common to find yourself having to do the same kind of task multiple times. And to do this, you often, do copy and paste, and you copy code from one part of your project to another part. You make a few modifications and you run it for that thing. All right. So this is my guideline. You should not copy and paste the same chunk of code more than 2 times. Okay. By the time you have to copy and paste the chunk of code a third time, meaning the same chunk of code is going to exist 4 times in your kind of project, at that point, it should be a function, right? So if you have a chunk of code and you're like, oh, I need to run this again, and you copy and paste it, like that's fine. Okay. That's like a common scenario. By the time but if you copy and paste it another time, so the same kind of chunk of code exists in 3 places, maybe slightly modified in each of these 3 places, by that time you should be like, maybe this needs to be a function, okay? And then if you find yourself about to copy and paste it a third time, so the same chunk of code is going to be in 4 places, okay, then it should definitely be a function. So that's kind of my guideline here. Okay, if the same chunk of code is going to be exist in four places in your document, that needs to be a needs to be a function. Okay. And so copy and pasting is okay. I would say your limit on copy and pasting is twice. By the third time you're going to copy and paste, make it a function. And the reason why is it's just better to change code in one location than to try to change copies of the code everywhere. Um, so, let's say, a common thing you might have to do is create a plot. Okay. And you run the plot, you create the base plot, then you add this line, this trend line, you add something else, and you add all kinds of things to your plot. And you might be like, okay, now I need to do the same plot but for another variable, so you copy and paste it. Okay. And if you find yourself having to do this multiple times, you should wrap all of that code into a function. And then later on, if you decide, oh, you know what? I want to change the way my plot looks. I want to, I want this line to be dotted, and I want this thing to be red, and this thing to be blue, or whatever. Um, if you had copied and pasted it like three times, you have to make those changes in all four locations, and it's easy to make a mistake. It's easy to miss one of those things. If you have a function, you just kind of update your one function, and then it will update everywhere, right? It will update everywhere. Okay. Um, you want to name your function so that it is clear what the function does. Okay. I am a terrible offender of this in my notes because in my notes I have these silly functions that don't really do anything, and I just call them f or f2. But those are terrible names for functions. Don't name your functions f or f2 or something like that. Okay. Um, Sometimes your function is going to return a true or false value. And if that's the case, name your function like a yes or no question, like is prime. Okay, is it prime? Yes or no, true or false. That's going to be kind of um, the like how you should name your function. Okay, and then keep your functions simple enough that you can kind of read it and understand it. If your function is getting too complicated, maybe break it out into two parts. Okay, I don't know. All right, let me give you your first view quiz answer, which is the letter C. C as in cat. C as in cat is the first view quiz answer. And yes, the view quiz answers are the same for both lectures, the 8 a.m. and 9 a.m. lectures. All right, so let's work through writing a function, and I'll kind of talk us through some function writing strategies. And just to kind of illustrate what we're going to do is we're going to code up what's called a bubble sort. Okay. So, R already has functions that can sort values. It's, there's no reason to do this, but um, I think it's still useful. So, the bubble sort algorithm is a very simple algorithm that can be used to sort values. It's not the most efficient, but it works, okay? And the way it works is, starting at the beginning of the list, you compare every adjacent pair of numbers, and if they are not in the right order, then you swap their positions, okay? And you do this until you perform this multiple times, and you do this until all of the numbers are in order. Each time you perform a sweep of kind of comparing adjacent values, um, you know, a number gets kind of locked into position. So um, you have to just do kind of like one less check every single time. Let me just kind of illustrate this. All right. So let's say we have this vector 5, 1, 8, 2, 4. Okay. During our first pass, we compare two adjacent numbers. We compare the 5 and the 1, and we say, are they in order? They're not. Okay. The 5 is bigger than the 1, so we swap their positions. Okay. So we swap the 5 and the 1, and if we have 1, 5, 8, 2, 4. Then we look at the next pair of numbers, 5 and 8. Are they in order? They are. So we don't swap positions. Then we look at the next two pair of numbers, 8 and 2. Are they in the right order? They are not. So we swap their order. So we get 2 and 8 here. And then we look at the last two numbers, 8 and 4. Are they in the correct order? They are not. So we swap their positions. So at the end of this, we have 1, 5, 2, 4, and 8. And we know because we have gone through the entire thing looking at every single number, every single comparing every adjacent pair, we know that the largest number is all the way to the right. Okay, we know that all the way to the right has to be the largest number. So we're going to do this again to just make sure all of the numbers are in order. And here we know 8 is in the correct position, so we can kind of we can stop after the third pass. So we don't have to compare 4 and 8 at the end. We can kind of lock 8 into position. So I'm going to say 8 is locked into position. I'm going to put that in italics. So I only have to compare 1, 5, 5, 2, and 2, 4, or whatever. So I compare 1 and 5. Those are in order, so I don't swap their positions. Then I look at the next two adjacent numbers, 5 and 2. Those are not in the correct order, so I swap their positions. And then I look at the next adjacent pair of numbers, 5 and 4. Those are not in the correct order, so I swap their positions. And I get 1, 2, 4, 5, and 8. Okay? And then I stop here. I don't need to compare the 5 and the 8 because I know the 8 is in the correct position. All right. Now, technically, our vector is already in the order, but the algorithm is already in order, but the algorithm doesn't know this. So we're going to keep kind of running this to just make sure everything is correct. And so we compare 1 and 2. They are in the correct order, so I don't swap. Then I go to the next pair of numbers, 2 and 4, and they're in the correct order, so I don't swap them. And I don't have to compare 4 and 5 or 5 and 8 because now that because prior to this, I'd run the sweep twice, and so therefore I know the 8's in the correct spot and I know the 5's in the correct spot. And now that I've run it a third time, I know the 4's in the correct spot. Okay, so the last time I just look at the last two numbers, 1 and 2. Are they in the correct order? They are. I don't swap them. And so now we know all of the numbers are in the correct order. 1, 2, 4, 5, and 8. All right. Here is a little animation on Wikipedia. We've got the numbers 6, 5, 3, 1, whatever. We're going to do bubble sort where you look at the first two pair of numbers. They weren't in the correct order, so we swap them. We look at the next two, 6 and 3. They are not in the correct order, so we swap their positions. We look at the next pair of numbers, 6 and 1. Not in the correct order, so we swap them. Then we look at the next pair, 6 and 8. 6 and 8 are in the correct order, so we leave them. 8 and 7, they are not in the correct order, so we swap those. Then we look at the next pair, 8 and 2. And we do this, and 8 reaches all the way to the end. 8 is in the correct order. Okay, or we know 8 is in the correct position. It's all the way to the right, so we can lock it in position. Okay, so we're going to put a little black box around it to say this is locked in position, and we do the same thing. We just kind of look at two numbers at a time. We ask if they're in the same order, or if they're in the correct order. If they're in the correct order, we leave it. If they're not in the correct order, we swap positions. And by doing this, the 7 is going to get pushed all the way to the right. Okay. And then we don't have to watch this all through the entire the animation, but it's a good animation. It's on Wikipedia and it explains how bubble sort works. Okay. So what we want to do is we want to code this up. Okay. And anytime you have to code something, you this is kind of the problem solving aspect, is you need to break down the big task into smaller tasks. Okay. You got to think about how do I break down the big task into smaller tasks, and you code up the smaller tasks, right? And if you can do that, then you can solve your problems. So we are going to say the bubble sort algorithm kind of consists of comparing two adjacent values and swapping them if they're not in order. And we can further break that down into just comparing two values and then swapping two values, okay? And then once we are able to do that, then what we need to do is we need to do that, but perform a sweep across the entire vector, right? So we're going to kind of compare values 1 and 2. Then we compare the next two values, 2 and 3, and then 3 and 4, and so on and so forth. Okay? And then every time we do a sweep, we have to kind of perform multiple of these sweeps. And then the following sweep, there's another position locked, and so we don't have to do the entire vector every single time. So when you start coding a function, uh, my piece of advice is do not start immediately writing a function. Okay. I always suggest working in the global environment and then and then testing out your little chunk of code, test it out with, similar cases. And if it works, then you can add more features and whatnot. And if it doesn't work, you can see because you're working in the global environment, you can see all of your values and you can see exactly where things went wrong. Okay. So let's just see if we could do this first. One of the first simple tasks, can we swap two adjacent values? So let's say I have x is 5, 4, 3, 2, 1. All right. And if I want to swap the two values, the first two values, I want to see 4, 5, 3, 2, 1. 4, 5, 3, 2, 1. Okay. So um, we're going to just start off with this very, very simple task. Can I write a piece of code that is going to perform this very simple task? And um, and we're going to see if we can do that. Okay. So this is what would happen if you start off writing a function immediately. Okay. So here I'm going to just write a function that's going to swap the first two values, function of x. I say, all right, let's take the second value, x in the second position, put it in the first position. And then let's take x in the first position and put it in the second position. And then once we do that, let's return x. And so I have x is 5, 4, 3, 2, 1. I call swap the first two, and then it returns 4, 4, 3, 2, 1. And so, to my credit, I had a very simple case and I knew exactly what it should result. And I checked on that and I didn't get what I thought. I was hoping to get 4, 5, 3, 2, 1. What I got was 4, 4, 3, 2, 1. So now I know something went wrong and I have to troubleshoot this and figure out what went wrong. Now, the problem with writing a function is that all of the values exist only inside the function and you can't really see what's happening um, to those values while you're in the global environment. Our studio does have features like a debugger where you can kind of set breakpoints and see what the value is inside the function and things like that. And it's a great tool, but I would say even easier than using the debugger is just to work in the global environment to get your code up and running first, and then wrap it into a function later. So let's just kind of see what's going on. So here I'm going to just work in the global environment. I'm going to clear everything out of the global environment, and I'm going to create my vector. X is 5, 4, 3, 2, 1. And I'm going to just try running those lines of code. And then I'm going to just check on the value of X after each piece of code I write. So I'm going to write X, take the X in the second value, goes into the first value, and then I'm going to just check on X. And when I do that, I see, oh, it's already 4, 4, 3, 2, 1. And then if I try to do X in the first position goes to the second position, I can see now this is going to be fruitless because that value of 5 got overwritten with this line. And so now when I take the value in the first position, it's already 4. And I try to put it in the second position, it's going to be 4 there. So there's no longer a 5. I don't have anything to do. So I have to figure out, okay, how do I kind of keep that? So um what I'm gonna do is I'm gonna create like a temporary spot to hold the 5. So I'm going to do x is 5, 4, 3, 2, 1. I'm going to take the 5, x in the first position, put it into a temporary spot. All right, and then I'll take x in the second position and put it into the first position. And then I'm going to take that temporary value of 5 and put it back into the second position. And when I do that and I check on x, this looks like it works. I get 4, 5, 3, 2, 1. Okay, so this seems like it's working. And just to kind of make sure it is working, we should test it out on other test cases. So again, I'm still working in the global environment, and I'm going to just test this again. I'm going to try x as the vector, 1, 2, 3, 4, 5, 6, 7, 8. I run the exact same code again, and it does swap the first two values. Okay, so the 1 and the 2 got swapped, and now it's 2, 1. And I go, okay, well, now I want to make sure that it's conditioned, right? I only want to swap if they're in the wrong order. If they're in the correct order, we don't want to swap their positions. So I'm going to take this line of code that I've had here, these lines of code, and wrap them with a conditional statement. I'm going to say if the x in the first position is greater than x in the second position, then swap them. Um, Otherwise, don't do anything. Okay. So here, um, if I have x is 5, 4, 3, 2, 1, and I run the code, then I do swap them. The 5 and the 4 switch, and I have 4, 5, 3, 2, 1. Okay. Um, Again, still working in the global environment. What if I have x is 1, 2, 3, 4, 5? I clear everything out. I run the exact same line of code. It's lines of code, and I don't swap them this time. And so this this seems to be working. Okay. So here the idea of just like kind of comparing two values and swapping them, that seems to work. Okay. So we're comparing two adjacent values. We swap them if they're not in order. That has worked. Okay. So now we need to do this, but we need to do it for all adjacent pairs. We need to kind of perform a sweep across the entire vector. And then if we perform a sweep across the entire vector, we need to once we succeed in that, we need to perform multiple sweeps um, to try to make sure all of the values are in order. So the way I'm going to do this is I'm going to um, what do you call it? Replace. I'm going to create a for loop. Okay. And the for loop is going to run through the entire vector. And I'm going to replace 1 with I and 2 with I plus 1, right? And so that way when I run it, I can create like a for loop for sequence length of x, and so I is going to go 1 through 5, 1, 2, 3, 4, 5, and I'll do it, the first time I is 1 and I plus 1 is 2, and then the next time I is going to update to 2, and then we'll look at positions 2 and 3. And so on and so forth. And so here I'm going to take the lines of code that I've written, throw it inside a for loop, and I'm going to do for I and sequence length of x. Okay, so let's try this out. Okay, so this is what I have. I have x is 5, 4, 3, 2, 1. I have for I in sequence length of x. And I've got if x sub I is greater than x sub I plus 1, then basically do our swap. And when I try to run this, I get an error. I get missing value where true false needed. And the error happened in this line for x sub I is greater than x sub I plus 1. Okay. And so this is why I say working in the global environment is helpful, because when you work in the global environment, you can see where things went wrong. Okay. And because if we're in a function, we wouldn't know, like, we would just know something went wrong, but it would be hard to know exactly, what's the value of I, what's the value of X, and things like that. When you're in the global environment, you can check all of these things. So here I'm in the global environment. I can ask, hey, what is the value of I? I is the value of 5. Okay. And what is the value of X sub I? X sub I is the value 5. Okay. And what is X sub I plus 1? okay, well, I plus 1 is going to be 6. And so we're asking, what is the sixth value of x? All right, and I'm getting an NA, okay? Because my vector is only length 5. With length 5, the sixth value doesn't exist, and we're going to get an NA. So that's why, all right? I'm getting a missing value. It says missing value where true false is needed. I'm comparing 5 to a non-existing value. And the issue is if my vector is length 5, I only need to do comparisons 4 times, right? I check the 1 and 2, 2 and 3, 3 and 4, and 4 and 5. I don't actually check 5 and 6 or something. So my sequence length isn't length of x, but it is length of x minus 1. So I just make that change right here. I do for I in sequence length, length of x minus 1. And then now I test it out. I clear out my global environment. rm list equals ls. X is 54321. I run the code. This is still working in the global environment. And I got, when I check on it, the number 5 has been pushed all the way to the right. Okay. So I started off with 54321. And then that number 5 has been pushed all the way to the right. So it seems like it's working, okay? Now, it's important though, just because it worked once doesn't mean it is completely correct. So write a few more test cases and just make sure it actually is working. So thoroughly test your code before moving on. So here is just another test case where I've got x is 125836, and I ask myself, okay, what should this look like once I do one sweep, okay? What I want to see is I want to see 8 get pushed all the way to the right, okay? And I run this code, and indeed, it looks like 8 has been pushed all the way to the right, okay? Let's just test this out one more time. And so here I just take a random sample of 10 numbers, or I take the numbers 1 through 10 and I shuffle them up. And then, so this is what X looks like, 8, 7, 1, 5, 4, 10. And when I run this, what I want to see is 10 get pushed all the way to the right, okay? And that's what we see. We see, 8 and 7 get swapped, and the 8 gets pushed until it hits the 10, and then at that point, the 10 gets pushed all the way to the right. And so that seems like it's working, okay? So now I feel like, okay, this code is working, so now let's move on, okay? And so what we're going to do is we want to perform multiple sweeps of the vector, okay? So we're able to perform one sweep and push one number all the way to the right. And what I want to do is I want to repeat this so that the biggest numbers get pushed to the right, and we're going to perform multiple sweeps, okay? And eventually, each time we perform a sweep, we're going to do one fewer comparison. Each time we perform a sweep, we can like kind of lock in a position. So we can test out the idea of doing multiple sweeps first just by very simply just copying and pasting the code. So I start off with x is 54321, and I run the piece of code that I have, and it pushes 5 all the way to the right, and I can just say, all right, well, let's just run that code one more time. I copy and paste it, ask what is x, and when I run it again, it looks like 4 got pushed all the way to the right. Okay, so far it looks like this is kind of working so far. So let's go ahead and just say like, all right, let's repeat this a bunch of times. So what I'm going to do is I'm going to run this loop, okay, this loop, and I'm going to put it inside another loop. I'm going to have a loop of loops, all right? So I'm going to have kind of these nested loops. We want to perform multiple sweeps. So we're going to take my currently existing loop, throw it inside another loop, okay? With a length of 5 in my vector, how many sweeps do I need to perform? I need to perform 4 sweeps. So I'm going to put that into a loop that has a length of x minus 1, right? So the inner loop is this part that I've coded is my inner loop. And then I have that inside an outer loop, which is going to perform multiple sweeps. So I'm going to do for S, for like which sweep I'm doing in sequence length, length of x minus 1. And I try it. I start off with x is 54321. I run my loop of loops, and indeed it looks like it has sorted it into 1, 2, 3, 4, 5. Um, Now, one thing is that there's a little bit of inefficiency because right now I haven't taken into account like locking in my positions. So every time I do it, the inner loop is gonna do length minus one comparisons. So it's every single time it's gonna do four comparisons. But technically, I only need to do four, and then the next time I only need to do three, then the next time I only need to do two, and then the last time I only need to do one. Okay? So so the first time we perform a sweep, we move through the entire vector length of x minus 1. The second time we perform a sweep, we only need to do length of x minus 2. And then the next time we only need to do length of x minus 3. Okay? So what I can do is I can start off by saying none of my positions are locked. And every time I run the inner loop, the number of positions that get locked increase by 1. So I'm going to start off with locked is 0, and then my locked is going to go up to 1. The locked number of locked positions is going to go up to 2, and so on and so forth. And then the how many comparisons I need to do is going to be the length of x minus 1 minus how many positions are locked. Okay, the length of each sweep gets adjusted there. There's a question. Isn't this still inefficient? Because what happens if we're trying to sort 1, 2, 3, 4, 5, 6, 7, 8? Then we're just sweeping a ton of times when we don't have to do it all. Yeah. So again, bubble sort isn't the most efficient thing. We just kind of um, yeah, it is not the most efficient algorithm, but this is the bubble sort algorithm in that we're going to just do comparisons every single time. Yes, we can improve by keeping track of other things. It says, can we create a Boolean flag to break from the outermost loop if there's no swaps occurring? So the thing is just because you didn't have swaps in the beginning doesn't mean you're not going to have any swaps later. So, um, you know, now you have to start storing a bunch of memory, like in memory, like how many swaps I've done. And the whole reason why bubble sort even existed in the first place was uh, it came about in a time when memory was very expensive or very limited, I should say. Okay. And so it only needed to keep track of basically two numbers at a time. Okay. Two numbers at a time in that it would just compare two numbers and swap them. So yeah, it is not the most efficient algorithm. Okay. It is not the most efficient algorithm, but um, but it but it functions and it only needs to look at two numbers at a time. But yes, lots of inefficiencies. But anyway, here, um, the length of each sweep gets adjusted. I'm going to increase the number of positions I get locked, and we will decrease how many swaps I need to do by locking in more and more positions. So anyway, we're going to test this out. X is 5, 4, 3, 2, 1. We run it. We get 1, 2, 3, 4, 5. Oh, that looks good. Okay. Just a little bit of stuff on that loop. So here, let's just try a bigger thing. I've got sample 40, 1 through 40 gets randomly shuffled. We'll try running the code. And when I run it, it looks like it got sorted into 1 through 40. So that looks pretty good. Okay, so I'm feeling pretty good. Let's take this code. Remember, this entire time I've just been working in the global environment, and this has allowed me to kind of troubleshoot and identify problems quickly. And so now I'm feeling pretty good. I'm gonna wrap it in a function. So I'm gonna take all of this code and just throw it inside function. I'm gonna call it bubble sort. And let's test out the function, okay? And I call sample x is sample 100. I call bubble sort. It looks like nothing happened. I look back at my code and I realize, oh, you know what? I never returned anything. So I just need to add one more line at the very bottom, x. This is going to be the value that gets returned. We're going to just return the vector x, and we'll try it out. So I shuffle up 100 values. I call that x, and then I call bubble sort on x, and it looks like it runs. Okay, it's in order 1 through 100. Okay, so just to recap what we've done, we broke down our tasks into smaller steps. We don't start working in a function right away. We work in the global environment. We write our code. And then when something breaks or doesn't work the way we want, we check the values in the global environment. We can see where things might have gone wrong. Okay. Every time you do that, clear your environment. Every time you change something and test it out again, and then add to your code incrementally. All right. And every time you do add something, test your code, test each change before moving on. You want to kind of make sure that it is indeed working. And I think this is going to help you write your functions and have kind of less pain or, just be a better way for writing your things. Okay, a couple things for efficiency. You can write your code as a script in R. You can put in remove list equals ls at the top of your script, and that's going to clear out the global environment every single time. And then you can kind of click source with Control Shift S or Command Shift S, and you can investigate errors. So you can write your script up here. You can click the source button or hit Control Shift S, and then you can go into your console and check and see how it's working. All right, let me give you uh, view quiz answers 2 and 3. The second answer is B, B as in bear. B is your second view quiz answer. And then your third view quiz answer is A as in apple. A as in apple is your third view quiz answer. Okay, I want to give you just some hints on getting started with homework 2. I know you're probably still working on homework 1, but homework 2 is out there and there's a bunch of different tasks, and one of them is to draw a game board. And this can be it can feel kind of daunting when you first have to do it. So I just want to kind of get you started with like drawing the grid line, okay? And again, you want to kind of keep your code flexible enough to allow for different columns and rows. But we're just going to kind of start off with like, what if I want to draw a 10 by 10 thing? Okay. So I'm going to create an empty plot calling plot new. And then the primary tool we're going to use is the line segment tool. And the line segment tool is you put in an XY coordinate of your starting point and then the XY coordinate of your ending point. So here, if I go from 0 to 0 to 10, 10, this is what the line segment looks like. What I strongly recommend for this problem in your homework is take a piece of graph paper or a piece of paper, just whatever, draw out the board on a piece of graph paper and then label the different coordinates. Your bottom left corner, 0, 0. Your top right corner, 10, comma 10. Okay. The bottom right corner is going to be 10, comma 0. The top left corner is going to be 0, comma 10, right? Label, label the coordinates. Draw lines. Label the coordinates of where your numbers are, right? Your first number is going to go maybe into position 0.5, 0.5. Okay. Label the coordinates, and then that will give you a sense of like what numbers you need to be plugging in. Okay. So here, if I want to draw a line from the bottom left to the bottom right corner, my bottom left corner is 0, 0. My bottom right corner is going to be 10, comma 0. So that's what I put in. Okay. I want to put in a line right above it, right, to draw kind of a grid. So the next line, I'm going to start off at 0, comma 1, and it's going to go across to 10, comma 1. So that's what I have, 0, comma 1, 10, comma 1, and it draws a line there. Okay, what about a third line segment? Okay, the third line segment is going to be at 0, comma 2, 10, comma 2. Okay, but when I do that, it doesn't look like anything got printed. And the issue here is that my window settings are all wrong. So I need to fix this, and I'm going to create my plot window. My X limits are going to go from 0 to 10. My Y limits are going to go from 0 to 10. Aspect ratio is 1, is going to keep squares looking like squares. And so I can go 0, 0 to 10, 0, 0, 1 to 10, 1, 0, 2 to 10, 2. And we've got that. And then so now I can say like, all right, I need to draw a bunch of horizontal lines. And so I'm going to just kind of repeat this with a loop. Each time I'm going to my starting and ending X is going to be 0 and 10, but my Y coordinate, the first time I'm going to do it with Y0, and then I'm going to do it with Y1, then with Y2, then Y3. I'm going to just replace Y with an integer. So I'm going to say for R in 0 through 10, And we're going to go from 0 comma R to 10 comma R. And that's going to draw 10 horizontal lines. I do the same thing, but this time with vertical lines. Vertical lines, my first one is going to be at 0, 0, 0, going up to 0 comma 10. The next one is going to be at 1, 0, going up to 1 comma 10. Then 2, 0, going up to 2 comma 10. So with the same kind of idea, I'm going to have another loop. Each time the X position is going to change, but the Y is always going to start off at 0 and end up at 10. And so I have a loop to draw my horizontal line segments, and then I have another loop to draw my vertical line segments, and this is how I have a grid. Okay, so I'm going to start off with this to try to draw my grid, and then from there I will add more things. And again, I strongly recommend you take a piece of paper, label all of your coordinates with a pen and with a pencil, and then that I think that will help you out with how you should draw your board. Okay, we will end here for today. Have a great weekend. It is Martin Luther King Day weekend, so there's no class on Monday, no office hours on Monday, and we will see you back in person on Wednesday. All right, so have a good weekend, stay safe out there, and we'll see you in person on Wednesday.